Okay, so here's homework number 10, the last homework. Explain which of the following are functions. What does it mean to be a function? A function, each x goes with only one y, not two y's. So, probably it's best to show so that's what a function is. Each x goes with only one y, not two y's. So in other words, you cannot have something like 1 going with A and then 1 also going with B. See, that's x values come first and then y. You remember that it's x, y, right? Whenever we do ordered pair, like two numbers with a comma, x is always first, then y. So that's the same x. See how that's the same x going with two different y values? That's what you cannot have. This is not a function because it does that. That's not a function. You have the same x going with two different y's. Each x goes with only one y to be a function. Okay. See right here? See how 3 is going with C and with D. So that's not good. That's not a function because that's the same x, 3, same x value, 3, going with two different y values, C and D, right? So is it a function? It is not because 3 goes to C and D. That's the problem. All right, what about the next one? This one. This one's a function because every x goes to only y. It is a function because each input maps to exactly one output. There it is. So there we go. I guess I'm on the wrong blank there, huh? It's a function because each input goes to one output. All right, so number 2, draw an arrow diagram. The domain and range. So which one has domain 1, 2, 4, 5, 8? 1, 2, 4, 5, 8. So this is domain and this is range. This is domain and this is range. Domain and range. So domain is where the values start. Range is where they end up. Okay. Now we want it to be a function. Want it to be a function. So first off, range CD. That means it's got to hit C and D. So A is not any good because they're not hitting C. It's not hitting C. It's got to hit C, right? If C and D are in the range, it doesn't just mean that they're in the circle. It means you got to have something hitting it. So that's the reason that is. Let me jump around here and show you what the issue is. Look at C. C's no good because C5 goes to two different things. That's an X. Domain is the X values. This is the Y values. So there's an X value, 5, going to two different Y values, C and D. Part D is wrong also because you see 4 is an X value going to two different Y values. So that's not any good. So the one that's a function is B. And how many different functions are possible? This is a weird question. How many different functions are possible? Well, basically, when you start off, I do it down here. You're going to go 1, 2, 3, or 1, 2, 4, 5, 8, right? 1, 2. Well, I don't even have room. Let me try to do it right here. So 1, 2, 4, 5, 8. 1, 2, 4, 5, 8. Each of those guys can go to C or to D, right? So there's 2 options for this guy, 2 options for that guy. This guy can go to C or D, C or D. So if you multiply those together, you'll get 32. 2 times 2 times 2 times 2 times 2 is 32. But there's 2 things you can't do. You can't have everybody going to D like that, and you can't have everybody going to C either. So subtract those 2 possibilities, and you get 30 different ways you could have stuff on this side going to stuff on that side. Okay, number 3. Make an arrow diagram for the rule +1. Which of these is adding 1? 2 goes to 5. Did that add 1? Is that +1? No. How about B? 2 goes to 2. Is that adding 1? +1? No. How about C? 2 goes to 3. Is that +1? Yeah. 3 goes to 4. That's 1 plus. 4 goes to 5. That's +1. 5 goes to 6. Yeah. It's not D. 2 goes to 3. That looks good. But 3 goes to 5. That's not +1. That's +2. So all of these are +1. So the answer is C. Okay, so now make an arrow diagram relatively prime. Relatively prime. What does that mean? Nothing in common. To be relatively prime means to have nothing in common. So does 2 have nothing in common? Well, I should say nothing divides into both except 1. Right, 1 goes into everything. So let's take a look at it. Let's see. Oh, this is kind of a weird one, huh? For the rule is relatively prime. Okay, so coming over here. So 2, is it relatively prime to 1? Yeah. Okay, 3. Yeah. Okay, 4. Here, let me show you where it breaks. 4 is going to 2. That's a problem. Why? Because 4 and 2 both have 2 in common, don't they? So relatively prime means nothing goes into them. But 2 and 4, they're not relatively prime because 2 goes into both of them. So they're not relatively prime. They should not be connected. We're only supposed to connect things. Make an arrow diagram for the rule relatively prime, which means nothing goes into the 2 numbers except 1. So it's not A because you shouldn't have 4 and 2 connected. Okay. How about, look at C. 2 connects to 4. Again, those are not relatively prime. So it's not C, right? 2 goes into 2 and 4. What else? How about, here we go again. D, 2 and 4 are connected. 2 goes into 2 and 4. No, so it's got to be B. Okay, now they're asking down here, they're saying, hey, which of these is a function? They're saying, parts 1 and 2 are a function, or only part 1 is a function. They mean the answer we got. Well, here's the answer we got, B, to part 2. This is part 2. So was that a function? No. See this x value here going to 2 different y values? That's not a function. So it can't be that option. Part 1 and 2 are functions? No way. Let's go back to part 1. Here's part 1. Our answer was C. Is that thing a function? Yeah, it's just one thing goes to one thing. That's a function. So part 1 exhibits a function. There's our answer. Okay, so here we go. They want me to do a rule. This is kind of tricky. So how does 6 become 13? How does 7 become 16? 9 become 22? And 10 become 25? What's the rule there? What's going on? Well, the trick is you can tell when 6 went to 7, 13 went to 16. It went up by 3, didn't it? So what that means is it's 3n plus something. Why? Because when n goes up by 1, you increase n by 1, the answer increases by 3. It's like if n was 6 and then it went to 7. Well, those are multiplied by 3, so that made the thing jump up 3. So we know it's 3n plus something. What? What is that something? Well, so this is the L. L equals 3n plus something. So now if we, how do we find the something? Oh, and by the way, we see it here too. As 9 went up to 10, that went up by 1. 22 went up to 25. See, it went up by 3. Anytime n goes up by 1, the other side goes up by 3, doesn't it? So it's 3 times n. Okay. So anyway, how do we find the other number now? Well, now we say, okay, if just plug one of these in. If you plug in 6, you're supposed to get 13, right? So if you plug in 6 for n, plus question mark, you're supposed to get 13. So the L is 13 when n is 6. So when n is 6, L is 13. So what's the question mark then? This is 18 plus question mark. Subtract 18 from both sides. So this is minus 5. I'm getting a little scribbly here. That means here, I'll just bring it over here. Minus 5 is the question mark. So the question mark is minus 5. Do you see that? I solved for this question mark. I knew the formula was 3n plus something, right? Because anytime this went up by 1, this went up by 3. So I knew it was 3n plus something, and then I found the something by saying, well, look, when n is 6, L is 13. 13n for L when n is 6. And I solved for the question mark, negative 5. So here's the formula. 3n minus 5. That's the formula. See, that'll work. That'll produce any of the numbers in the other table. You can try it out. Put in 6. What are you going to get? 3 times 6, 18 minus 5. See, it's 13. Put in 7. It's 3 times 7, 21. Minus 5, what's that? 16. Yep, comes out 16. Right? Put in 9. 3 times 9 minus 5, that's 27 minus 5, 22. Sure enough, etc. See, it's working. That's the rule producing everything in that table. Now let's try the second table. This one's more tricky. I think it's more tricky. Let's see. So I'm looking at this table now. Yeah, this one's tricky. You just got to try different things. There's no easy way here. It's basically, can you see what it's? I just try different stuff. You know, I look here. I go, well, that's going up by 1. And so that went up by 11. Maybe it's just 11n, but if you fool around with that for a while, you see it just doesn't work. It just doesn't work. Basically, here's the rule. You just take this number to the second power. That'd be what, 4? And then you add 3, and you get 7. Now, does that always work? Yeah, take the 5. Second power, what's that? 25, add 3. See, 28. See how it's working? Take that number, 6, square it. What's that? 36, add 3, 39. See, it's working. 12, square it. What's that? 144, add 3, 147. So it's n squared, add 3. So that just takes some practice of looking for formulas on that one. So the other one was what? 3n minus 5 was the other one that produces this table. So that's just tricky. It just takes practice trying different things. Number 5, consider the two function machines that are placed as shown. Find the final output for 0, 5, and 12. Okay, so what are they talking about? Well, they want me to put 0 in here. So 0. And what does this function do? Times 6. 6 times 0 is 6. And then that goes in here. And this function is x add 3, so it's 6 add 3, comes out 9. Does that make sense? So you put in 0, it's multiplied by 6. Oh, wait a minute, 6, what am I doing? This is nuts. 6 times 0 is 0. It's not 6. So then 0 goes in here, and 0 add 3 is 3. There we go. It comes out 3. Okay, let's try the next one. Now we're going to put in 5. Put in 5. It's 6 times 5, right? Whatever you plug in times 6. That'd be 30, and then put that in here. And whatever you plug in, add 3. 33. The middle one's 33. Let's do one more. The last one here. Put in 12. 12. 6 times 12 is 72. 72 goes in here, and then you add 3. 75. There we go. Okay, here we go. A ball is shot out of a cannon at ground level. We know that the height, h, in feet after t seconds is given by that formula. Find them. Okay, so the formula is h of t equals 144t minus 16t squared. So they want h of 1. They want to know how high is the cannonball after 1. What is that, second? Yeah, t is seconds, yeah. Anyway, plug in 1. Plug in 1 for t. So here's t. It goes there and there. So you plug in 1 in both slots. Like that. Minus 16. Is that? I think that's 128. So the cannonball is at a height of 128 feet after 1 second. Let's try the next one. Next one, h of 8. So h of 8. Plug in 8 for t. And you're going to need a calculator. Okay, and that comes out on my calculator, 128. Interesting. It's at 128 feet high after 8 seconds also. Okay, let's try another one. Let's try h of 3. Plug in 3 for t. And so hit the buttons on your calculator. This is 432 minus, let's go 16 times 9, 144. And I'm getting 288 feet tall after 3 high. The cannonball's 288 feet high after 3 seconds. Finally, the last one is h of 6. So I'm kind of running out of room here. Here, I'll go to a fresh screen. So h of 6 equals 144 times 6 squared minus, oh, not squared, 144 times 6 minus 16 times 6 squared. Okay, let me see, we get 864 minus 576. $288. There we go. All right, so why are some of the outputs equal? Let me go back. What were they? 128, 128. 288, right? Yeah. Why are some of the outputs equal? Well, what's basically happening is we're taking this cannonball and we're shooting it up and it comes down. Well, at 1 second, it's at 128 feet up. Well, at 8t, down here, this is time, t in seconds. This is height, h, on this axis. Instead of y and x, we have height and time. It's at 128 feet high at 1 second and at 8 seconds. And it's also at 288 feet at 3 seconds. It's right here at 288 feet high. 288 feet high, and at 6 seconds. Same height. At 3 seconds and 6 seconds. The cannonball. Right? It goes way up and way down. So it reaches all, it hits the 128 height twice, 128 feet high, going up and coming down near the end, right before it hits the ground at 8 seconds. And then it hits the height of 288 feet at 3 seconds going up and at 6 seconds coming down. So it's B, because the ball is shot upward, then falls to the ground. Choose the correct graph. So, that's hard to do. So, which one is correct? Well, okay, well, let's go through it. We know A is not the answer because, look, it hits the ground between 4 and 5 seconds. We know at 8 seconds, it still hasn't hit the ground. It hits the ground after 8 seconds, so it can't be A. Okay, next, it can't be B because B only goes up just above 150 feet. We know this thing is over 288 feet, so it's got to be C. Okay, so we know the answer is C. This is the right graph. Now it says, okay, using the graph found, when is the ball at its highest point? Well, can you see the highest point looks like it's right there, isn't it? Isn't that the highest point? And where is that? Bring it on down. Boom, right there. Now, it's hard to tell where that is exactly. It turns out that if you look really closely, this spot is 5, right? So the spot where, so the purple spot right there must be 4.5. That's t equals 4.5. And they say, what's the height at that instant? So they want you to plug into the function. Let's go grab the function. What was it? This function, 144t minus 16t squared. T minus 16t squared. That's the height. So now if I plug in the 4.5 seconds, that's at right here at 4.5 seconds, right between 4 and 5, it's going to be at its tip top. If I plug in 4.5 for t, 4.5 seconds, hit the buttons on the calculator, the height will come out to be, what? 324. 324 feet high. That's the highest the ball gets, 324. The cannonball gets up to 324 feet. That looks right. It's a little over 300 on the graph, so that's right. Okay, next part. Explain how you know it takes 9 seconds for the ball to hit the ground. Well, right there, it hits the ground. That's right in the middle of 8 and 10, so that must be 9 seconds. The graph crosses the T. This is the T. See the little T there? The T axis when T is 9. Next, what's the domain? Domain, what domain is? That means the width. The domain is the width. It goes from 0 to 9. So it's this one right here. Between 0 and 9, it's equal. See, it's got the solid bars. It can be equal to 0 and equal to 9. What is the range? The range is the up and down. And it goes from a depth of 0 to a height of 324. You can't see option C. It's off the screen right now. Shows height between 0 and 324. That's the right answer, C. Okay, so last problem. This is kind of a weird pattern thing. So what do they want me to do? They want let S be a function that gives the total number of lines in the nth figure. This is tricky. So first off, what's the pattern? Well, they have a triangle, and then it says assume the pattern continues. Each tile is divided into 4 tiles in the subsequent figure. Each tile is divided into 4 tiles in the subsequent, the next figure. So each tile is divided into 4 tiles. So this tile, one tile, this 1, becomes 1, 2, 3, 4. See that? 1, 2, 3, 4. So there's 1 tile here, 4 tiles there. So how many tiles in the next one? Well, we have, we have it, let me see where, it's right here. No, that's not very good. Let me try again. It's right there. Right, and then they put, right, because it's number 1, and they go 2, 3, 4. See how they make it 4 times as many? See that? They just break it, the main tile, into 4 times as many. So that's the pattern. So they just keep breaking. How many tiles do we have here all together? So there's 1, 2, 3, 4, right? Well, I mean, I'm probably confusing it. There's 3 in the next row. Next row, there's what, 1, 2, 3, 4, 5 in that row. 1, 2, 3, 4, 5, 6, 7 in that row. Did you track with that? Add that up. What's that? 10, 16. So you see the pattern, 1, 4, 16 total tiles. What's a formula that can do that? It's multiplying by 4 every time, isn't it? 1 times 4 is 4, times 4 is 16, times 4 is going to be 64 is the next one, etc. It's just going to keep multiplying by 4 every time. Well, what's a formula that does that? Basically, you've got to put 4 to the n minus 1. Why? That's pretty tricky. Well, it's because of the fact that this is n equals 1. This is the first figure. This is n equals 2. This is n equals 3. See, when I plug in 1 here, I'll get 4 to the 1 minus 1, which is 4 to the 0. I don't know if you know, but anything to the 0 power is 1. That's right, 1 tile. If you plug in 2, now plug in 2, plug in a 2 here, you'll get 4 to the 2 minus 1, 4 to the 1, 4. That's right, that's the next one. Now plug in 3, get 4 to the 3 minus 1, 4 squared, 16. Yeah, see, it just keeps multiplying by 4. So the formula is 4 to the n minus 1. That's kind of tricky.